Welcome to Honors Physics Podcast. This is question number 24 from Chapter 18. We are seeing that there are four charges, each with a magnitude of 2 microcoulombs. 2 are positive and 2 are negative. They're fixed at the corner of a 0.3 meter square, one in each corner, so that the net force on any charge is directed toward the center of the square. So we're supposed to draw this arrangement. It's fairly obvious that as we take a look at this, we have to alternate. So we're going to have a positive, and then a negative, and then a positive, and then a negative. And we can take a look, if you think about it like this, from this charge's perspective, it's being pulled this way and being pulled this way from opposite ends of a square, so they're equidistant apart. And then it's also being pushed this way slightly, which means that overall our net force is going to be this direction. And the same thing, you can see the symmetry would happen with the positive charge here and the negative charge here and the positive charge here. So that is not a big thing. To find the net electrostatic force on each charge, we have to take a look, and we should understand that for each of them, the electrostatic force is going to be the same in magnitude. Right? And if you take a look, think about the positive charge here. It's going to have a positive attractive force this way, an attracting force this way, and then a repulsive force this way. And we're going to have an attracting force this way, an attracting force this way, and a repulsive force this way. And then similarly, attracting, repulsive. So what we're going to find is that F net on each of them in the x direction is going to be just, for instance, on this charge right here, it's going to be the force from here subtracted, or subtracting, the x direction component of there. Now the nice thing is, this goes at an angle of 45 degrees, so we can just simply add in the force in the x direction from the one corner plus the force from the opposite corner times the cosine of 45. And in the y direction, F net in the y direction is going to be equal to Fy from the corner plus the F from the opposite side times the cosine of 45 again. I guess technically we should say sine of 45 here, but sine of 45 and cosine of 45 are the same. So these two forces right here are going to be the same. They're going to be k times 2 times 10 to the negative 6th squared divided by our distances squared, so 0.3 squared. This one here, our F opposite, is going to be the one that's slightly different. It's going to be k times, again, same charges, 2 times 10 to the negative 6th squared, because we have two of them, but then we have a right triangle. This is 0.3 meters, this is 0.3 meters, this is 0.3 meters times root 2. Right here. So our distances in between are 0.3 times root 2 squared, which is going to be equal to 2 times 0.3 squared. And again, I'm not going to add all those up for you, just as I did in the in-class portion, but I can trust that you are algebraically inclined enough to do so. If you would like the answers, you can come and see me in class, and I will give you the actual answers. This is question number 24 from Honors Physics Podcast, Chapter 18.